Okay, so the second harder vector subtraction question is very similar. A robot-controlled submarine is sent under water to search an area for a sunken ship. The submarine is programmed to travel at 2.5 meters per second at a bearing of west 25 north. The submarine is located 500 meters away from the stationary mothership after 7 minutes at a bearing of north 58 west. What is the velocity of the underwater current? So once again, we are asked for something other than the resultant. In this case here, the current, right? And we know that resultant is boat plus current. In this case here, we're talking about a robot-controlled submarine. We'll just call it a boat for ease of discussion here. We're solving for the current, so current is going to equal resultant minus boat. So we need to figure out what the resultant and the boat vectors are. Now the boat one is easy. The submarine is programmed to travel at 2.5 meters per second at a bearing of west 25 north. The current, a little current issue, we have to deal with this here. The submarine is located 500 meters away from the stationary mothership after 7 minutes. Now, the submarine velocity was measured in meters per second, and so we need to come up with a velocity for the resultant of this submarine here. And all we know is that it's 500 meters away and it's 7 minutes. So we're going to have to go back to our V equals D over T formula from grade 10. 500 over, now the time, we're given 7 minutes, it has to be in seconds, so we're going to have to convert that to seconds. 7 minutes times 60 seconds is 420. So you get 500 divided by 420. And that works out to 1.19 meters per second. So my resultant is going to be this 1.19 meters per second, and the resultant bearing was north 58 west. Okay, so we're going to have to find our current, we're going to have to go resultant minus boat. Resultant here, subtract the boat. So we're going to have to turn that boat into a minus B, so it's going to be the same thing. It's going to be 2.5 meters per second, but instead of west 25 north, it's going to be east 25 south, and we're going to add those together. Just need to make some more room here. Okay, so we're going to go north 58 west. Here's my north 58 west. Again, we're going to have to go by scale diagram. So something like 1 centimeter equals 2.5 and 1.19. We're probably going to have to go with 1 centimeter equals about 0.2 meters per second, something like that. This is actually a pretty challenging question. The result north 58 west. So this angle here is going to be 58. It's going to be more than that. North, and it's 1.19, something like that. 58 in there. My minus B is 2.5 east, 25 south. Okay, so east from there. East, let me get rid of this arrowhead here so we can see the end of the vector a little bit better. East 25 south, and that's 2.5. So it's actually going to be something like that. Quite a bit past, I think, if I'm not mistaken. And then my overall current of this river that it's in, current is going to be this value right here.
To the office, please.
And you'll have to do a measurement with a ruler and a protractor to find out. But that should help you with those two questions. I hope that works for you. If not, come and see me.